All right, lovely sixth graders. Here we go. We're going to do our test review for the Chapter 11 test that you just took. All right. First two questions that you had to do with mean. So the first two test questions revolved around finding the mean. Remember, when we're finding mean, you needed to add up all of your numbers, so the data points, and then your next step was then to divide by however many numbers there were added together. So for this first one, you're looking at the number of weeks in training. You have the numbers 8, 12, 4, 19. You're adding to that another 12, 15, 20, 23, 9, 18. And then we had 14 and 16. So it's a total of 1, 2, 3, 12, which you can see as well, 12 numbers. So when you added them together, you should have gotten 180. And remember, for this test, you could use a calculator, so hopefully you did that. It made it much simpler. You divided the 180 by 12, so that's the second step, and answer would have been 15. So the mean for the number of weeks training would have been 15. Next, number 2, we had our set. This one includes 5. I'm going to do that over here. So we added together 25, 16, 20, 21, and 20 as well. Again, first step for finding mean or average is to add all your numbers up. You get 102, and then divide. There are 5 numbers in the set, so you're dividing by 5. Answer comes to 20 and 4/10. So when you're dealing with a lot of numbers like this, make sure you use a calculator. You want to work smarter, not harder. Let it do the computations for you so you can focus on the steps. All right, the next two problems you did revolved around finding the median. We know median means we're looking for that middle number. So first step would have been to order your numbers from least to greatest. So I'm going to do that right now. We have numbers in our 20s, so it would be 27, followed by 29. Then we had 33, 35, 37, and 37 and 39. So you need to order them first from least to greatest. And then from there, you're crossing them out. So pairing them up, small, big, small, big. This time we're left with 2 in the middle. So to find the median, we needed that middle number. As you can probably see, halfway between 33 and 34, 33 and 35 is 34. But if you didn't know that, you would have taken 33, added it to 35, for which you get 68, and then divided that by 2. Indeed, answer is 34. And then you would do the same process for the next set, which also had you find the median, so the middle number. So we're going to order those. It would be 10, followed by 12, 14, 15. If you have your scratch paper, you can check to see, did you make sure you got them in order, not leaving off 18 because there are 2 of them, so it needs to be written down twice. 21, 22, 24, and 25. So you get a total of 11. So after you cross off small, big, small, big. So pairing them up, you would have seen 18 in the middle, so your median was 18. All right, that's the first 4. We're going to continue with the next group of problems. So your next one, number 5, was mode. So you're going to find the mode, and the mode is the number you see the most. So we're looking for, not this one, in this set, which number do we see the most? So it would be, I see 6, 1, 2, 3 times, and that would be the number that appears repeatedly the most often. So mode would have been 6. And for number 6 itself, so that's the number. For number 6 itself, we had to find the range. That's where we take the largest number in the set, which is 55 here, and we subtract the smallest number in the set, which is 37. That's going to give us our range for this data set. In this case, it is 18. So the answer range would be 18. So go ahead and check with your work because you did this online and hopefully you are noting your steps. Number 7, you were to take the number of wells cited, that data chart, and find the mean, oops, I left that off, the mean absolute deviation. So we're talking about finding MAD. Now we use what we know about finding the mean to do that. So you would have taken all these numbers, 23, 8, 52, 7, 6, 12, 15, and 30. You would have taken all those numbers, and just like when you find the mean, you add them all up, and that gave you a total of 153. There are 8 numbers in the set, so to finish finding the mean, you divide it by 8, and you were given the number 19 and 125 thousandths. So this is the number we're comparing each one of these data sets to, 19 and 121 thousandths. All right, from there, we do have to find their distance from this number. So I'm going to write my numbers here, 23, then we had 18, followed by 52, 7, 6, 12, and 15. We want to find their distance from, so it's absolute value, so remember it's going to be a positive number, distance from our featured number, 19 and 125 thousandths. So I know, again, this is a lot to keep track of, but that's why you have your calculator. You would type in 23 minus 19 and 125 thousandths. So after you put that in, you would have gotten the following number. So 3 and 875 thousandths. You did the same thing for 8. Ooh, that's 8, not 18. 8, you would have done the same thing for 8. So you typed it 8 minus 19 and 25 hundredths. You're finding, it would have given you a negative number, but again, we're talking absolute value. So it's a positive because it's a distance. You get 11 and 125 thousandths. So you would have done the same process, 52 minus 19 and 125 thousandths. So as you can see, all you need is your calculator just so you can get all this done. I'm going to write these answers down. So then after we did the same thing for 7, we would have gotten a negative number. And we realize we're talking absolute value, distance, so it's a positive number we're working with. So for number 6, you did 6 minus 19 and 125 thousandths. You would have got 13 and 125 thousandths. Oops. Running out of space. 13 and 125 thousandths. For 12, you would have gotten 7 and 125 thousandths. Again, absolute value, so you're looking at it being positive because it's a measure of distance. And then 14, oh, and I left off 30. So 15, here we go, you would have gotten 4 and 125 thousandths. And then 30 minus 19 and 125 thousandths would have brought you to 10 and 875 thousandths. So as you can see, calculators are very handy for this, so you're using them. All right, from here, after we've found each one of our numbers, distances from our featured number, 19 and 125 thousandths, all that's left is to find their mean. So you take all of these and you would have added them together. After you add them together, you would have gotten 95 and 25 hundredths. And because there are 8 numbers, you divide it by 8 to give you the average distance each one of these numbers is from the mean. And you would have gotten 11 and 90 and 625 tenths, hundreds, thousands, 10 thousandths. Ooh, 100 thousandths, woo, big, well actually a small number, small digits, but our directions did say we're going to round to the nearest hundredth, so we're looking here in the hundredths place, you look behind it, it's 5 or more, so you raise the score, answer 11 and 91 hundredths, after of course you round it. So a lot of steps. You take it one by one, but you can do it. Next problem was to use the table. So this would be for number 8. We're looking for which measure of center best describes this information. All right, when I'm looking at these 8 numbers, I see 10. To me right now, it's so far away from all the other ones, it looks like it's possibly an outlier, which means mean is out. So we can't use mean for that. Next up, we can use median as long as we don't have any big gaps in the center of our data. So as I'm looking through it, the rest of them are pretty close together. So median is a possibility. Mode, we see 50 a couple of times. But because it's not the majority of the numbers, we can't use mode. So median is our best bet. We're not going to use range because, again, of the outlier. So the median would be the best measure of center for this particular set of information. And now to 9 and 10. We're going to do 9 and 10 together. Because number 9, you're asked to find an outlier. And to be able to do that, you do need to find the interquartile range, which is part 10. So we're going to do this all together. First step would, of course, be to order your numbers from least to greatest. So I'm going to do that now. We have 6, 15, 18, 20, 21, 22, 24, 25, 26, almost done, 28, 29, and 30. So let's make sure we didn't leave any off. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 there. 2, 4, 6, 8, 10, and 12. So we have them all there. So that part we don't want to mess up on. All right, from here, we have to find the median. So that middle number is going to be the interquartile 2. So marking off small, big, small, big, small, big, small, big. You know the process. You're left with 2 in the middle, which means we're looking for that number that's halfway between 22 and 24. You guessed it, 23. So that's broken our information into the bottom half and the top half. All right, our bottom half is where we're going to find quartile 1. So we look for the middle number there. So we have small, big, 2 left in the middle. We need that middle number, which would be 19. So quartile 1 ends at 19. We're going to do the same thing for quartile 3. Okay, we have small, big, small, big, small, big, 2 left in the middle because it's not an odd set here, not an odd group of numbers here. So we're looking for that middle number, and boy, did this come out nice for us for 27 because it's halfway between 26 and 28. Now, RIQR, we're going to find first here because it's easiest. We take our 27, quartile 3, subtract 19, our quartile 1, and our difference is, it's supposed to be 27. Let's try that again. 27 minus 19, difference is 8, so our interquartile range would have been 8. So for number 10, you should have the number 8. From there, this IQR is what we use to find if there are indeed any outliers. We take our interquartile range and we multiply it by 1.5. And when you do that, you get 12. So we're looking for any number that is more than 12 away from quartile 1. And we're looking for any number that's more than 12 units away from the end of quartile 3. So quartile 1 was 19, so you do 19 minus 12. We're looking for any number that's farther away than that. So 19 minus 12 is 7. Do we have a number that is smaller? Oh, you can't see it. Do we have a number that's smaller than 7? Indeed we do. 6, so 6 is an outlier. And do we have any number that is, let's go to quartile 3, 27 plus 12, that brings us to 39. Do we have any number larger than 39? Do we have any number larger than 39? Well, going up and looking, nope, we end at 30, so there's no outlier there. So the only outlier for this set of data would be 6. And the reason for, because it is more than 1.5 times away from the quartile 1. So because it's more than 1.5 so 1 and 5/10 away from our interquartile range, which is for the first quartile. Got it out, and we're done.